Welcome to Miss Hasegawa's Science Class. Welcome to our wonderful world of science inquiry, and I'm so grateful that you can join me in this journey. Now, inquiry. We learned that word last time I saw you. Remember, inquiry is just a very fancy, smanchy word to question. So today, what our question is and what we are going to start diving into as you join me in this online learning, or this time of online learning, is basically, why does something stick? Maybe also, why does some things not stick? So let's focus on why some things stick. Now I want you to take a moment and really think. Look around you. Look around your house and think what around you sticks together. Just take a second. Just a little bit longer. Think what sticks together around your house. Maybe you thought about magnets. Magnets stick together. They can stick to each other too. What about gum? If you're a gum chewer, gum sticks together and it sticks to other things. And some of you, grossly, like to stick it under tables. Don't do that. Never stick gum under tables. It's gross. Also, Velcro. Velcro sticks together. It's like this cute little outfit that I have for my doggy. It has Velcro on it. Velcro sticks like that together. Also, if you know what saran wrap is, saran wrap or plastic wrap can stick to things too. It can very much stick to itself. Sometimes it can even stick to you a little bit. And it can stick to other things. Like I could probably stick it to this whiteboard. Look at that. But the Velcro won't stick to the whiteboard. It just falls down. The magnets won't really stick to the Velcro. They just kind of just fall off. So why does some things stick together while others don't? So before we go into that, because that's a very loaded question, meaning that's a very broad question. Because if you really think about it, why does some things stick together and why others don't? Well, you could say, well, the magnets, that's because they're magnets. Velcro because they're Velcro. Saran wrap because, oh, that's saran wrap. It's plastic wrap. So basically, if you're all kind of thinking that, you are right. They're all basically different things. So they all stick in different ways. So let's focus on why one of these sticks to another. So let's focus to why is this saran wrap sticking to the whiteboard right now? What does that have to do with? So that is us asking a question. Remember, when we ask questions and we're going in this inquiry, we're following the scientific method. I showed you something like this last time, where we start with a question. Our question is, why does that stick together? So we got to do some research. We got to figure out why. We have to form a hypothesis. Hypothesis, another word I went over. Remember, hypothesis is just an educated guess. Then we go with an experiment, and we test our hypothesis with an experiment. As we go through the experiment, excuse me, as we go through the experiment, we analyze the results, we draw conclusions, we see if it's true, we see if it's not true, and then we kind of write a report about that. We draw conclusions from that. If our hypothesis is wrong, well, back to the drawing board, we got to figure out what actually fits the answer to our question. I also showed you this, where we're going through our scientific inquiry, where this is a continuous cycle, where, again, starts with a question, and it goes with a hypothesis, a guess, an educated guess to our question. We test it, we observe, we record, we present, we reflect, and we do it all over again. Scientists love questions, and more than questions, we love figuring out why things happen. So, when we are going through this inquiry, so as we ask this question, why is this sticking? Why is it sticking? So we got to think about, basically, models. So today we're going to talk a bit about models. And what is a model, you might ask? Well, a model is just basically a representation of phenomena. Another word that we learned last time, phenomena. Phenomena. So phenomenon and phenomena are basically the same word. So phenomenon is the singular. So you're talking about one phenomenon, while phenomena is plural. It's talking about multiple phenomenons. And remember, phenomenon is just basically anything that's observable, anything that we can see, anything that we can explain. So it could be anything. So this is a phenomena that we can kind of see. So models are great. They're used to basically either predict something, predict behavior of real objects. They're not really meant to be big predictions. They can be used as predictions, but more of like a forecast. We want it to be more reliable. So let's kind of think about more of what models are good for and how to make a good model before we dive into what models are and different types of models and making our own model. So what makes a good, reliable model? So in order for it to be reliable, that means that we can depend on it. It has to come from dependable observations, reliable observations. That means that it has to come from a really good observation so that we can create a model of it. Models also need to be able to explain the characteristics of the observations. That's really, really important. Their model has to be self-explanatory, meaning your model has to stand on its own. So when someone's looking at your model, they know exactly what they're looking at and they know exactly what it is that you made and exactly what's going on. So models have to stand on their own. They have to be able to explain the characteristics. They also need to be able to thus explain the phenomena. They need to show what's happening. And they must also be able to be refined, meaning that someone comes along and they think of something better or they understand the phenomena better, that they can go back to your model and change it. So models must be able to be updated, essentially. Okay? So let's also go over what models can and can't do. They can't predict the future. So I know I said predictions, where they can guess the future, but they shouldn't really be used to predict the future. More of like a forecast, more of a guess of saying if this happens, then this most likely will happen. Just like the weather. You have the news, they forecast the weather, but it doesn't mean that it's 100% going to happen, right? So they're just approximations. They aren't 100% accurate, and they're not meant to be accurate. No model can be 100% accurate. They can also be wrong. That means that they can be wrong in some way, but they're really used to be useful. So a good model is a useful model. So let's go over different types of models. I'm looking at my desk here and to see what we've got. So first, let's kind of go over diagrams. Diagrams are models. It's a picture. So this is a great model. It's labeled. We're able to see what everything is. It's got plus signs, minus signs. It's labeling the different parts of the model. I can really understand the phenomenon in this picture. I can understand what I'm looking at. But I'm going to show you a bad model. This is a model of the same thing. It looks really cool, because you can tell it's an atom, but it's not a very good model. It's good in a sense that it's pretty, but it's not good in a sense that it's trying to explain what an atom is. That doesn't do a very good job of explaining. This does a great job of explaining. This is a good model. This is the type of model that I want you guys to start creating. Remember this. Good model. Bad model. Other types of models. So these are also types of diagrams and pictures that you can use. We'll focus on the bottom one. The bottom one is showing basically a phenomenon called Newton's third law of equal and opposite reaction with Newton's cradle. It's labeled, it has arrows, it's showing what the little marbles represent. Newton's cradle also is a great way to explain conservation of energy. So models can be used to explain different things. So now we're at a physical model. This is a physical model. And this explains the conservation of energy. What is the conservation of energy? Well, basically, it just means that energy can't be created or destroyed. So, if we were not on Earth right now, imagine we were in space, and I let this go. This would keep going on forever and ever and ever and ever and ever. But it stops here on Earth, because what does Earth have that space has very little of? That's keeping us to the ground. I hope you're thinking of gravity, because gravity is what's slowing that down. This is also a physical model. Again, this isn't really a scientific model, but it does have a purpose. Its purpose is to show the major landmarks of Tokyo, and also to look really cool. So it shows Mount Fuji of Japan, which is near Tokyo, and a lot of the major buildings. This is also a physical model. Even these little guys are models. And this one is a model. They're not great models. I mean, we don't really know what you're looking at here, but you get an idea. They look cute. And that's the purpose of that model. there's also types of models that can be simulations. So let me bring up a simulation from my iPad here that you can use, and simulations are even really great models because then you can use those to better understand something. So this is a model of the human anatomy, of our skeletal system. And simulations are great because you can move it, you can see how things are connected, you can get a closer look, you can click on things and get a better understanding of whatever you're looking at in this model. So simulations are one of my favorite types of models because they're really cool. They're very interactive and really help you understand the phenomenon that you are looking at. The last model I will go over are mathematical models. Math can be a model too. Math is great because it can explain some kind of phenomena that we're seeing that's kind of hard to describe by a picture. So it can be described by math. This is a mathematical formula to describe force. So force can be understood, and force is calculated by multiplying something called mass by something called acceleration. So math could also be used for a model. So these are all different types of models that we can use. So let's think. I have a model right here of me doing this, where I rub the balloon on my head and I hold it up and my hair sticks to it. So let's look at a model of that. I can draw a model of this. This is phenomenon, no? So when you look at my picture, and if you've been looking at it through the video, you're probably thinking, what the heck is that? Exactly. It's not a good model right now. What does it need? You got it. I hope you were thinking it. It needs labels. It needs to really show the characteristics of the phenomenon that I experienced. I can't really tell, you guys probably can't really tell either, what is happening. So I need to label it. Like, who's that? That's me. So I would write Mrs. H. This is my hair. It's sticking up. So I would just kind of label this as my hair. This is the balloon. Now I need to show kind of what's happening here, because not all of my hair is standing up, only some of it. And some of my hair is also not really standing next to each other, they're just standing next to the balloon. So in order to show that attraction, so in order to show things that attract, I use arrows. Arrows that point to each other like this is showing that they have an attraction for each other. Now, if you notice, my hair is also not standing or attracting towards each other. They're kind of repelling a little bit. So to show that they're repelling, I can have arrows that point away from each other. This is showing that they are repelling. So if we have arrows that point away from each other, that shows that they repel. That is a better model. That is the type of model that I want you guys to draw. So the model that you guys are going to draw is going to be about something called a Van de Graaff generator. Do you know what that is? I'm going to show you. So this is the type of phenomena that we're looking at. So I'm going to show you some phenomena with the Van de Graaff. Ooh. Here is our super cool Van de Graaff generator. Okay? I'm going to put my pans on top of it. Alright, so think about the Van de Graaff. This is metal. Think about this. These are pie pans. Pie pans are also some type of metal. They're like aluminum. I have 3 of them. I'm putting them on top, like this. And I know you've probably never seen a Van de Graaff generator before, but I want you to think for a moment. What do you think might happen if I turn it on? Well, let's find out. Gonna turn it on. And we're gonna watch what happens. Crazy! You wanna see that again? Let's rewind it. So cool, right? So this is super, super, super cool. This, oh, I gotta do it. Let me. So I want you to draw a model of that, of what is happening. I will give you a diagram so that you can help draw the model yourself, but I want you to start with practicing how to draw a model by drawing a model of what just happened. Okay? So today we talked about the scientific inquiry cycle, the scientific method. We talked about models, the different types of models, and now you're going to draw your own model based off of this phenomenon. So I'll leave you with that, and I'll see you next time. So cool!